Okay, so the remaining three methods to determine if triangles are congruent will be your angle, side, angle, your angle, angle, side, and then we're going to talk about hypotenuse, leg, and there's dealing specifically with right triangles. But these five will encompass the way that we can tell if triangles are congruent. So again, now we are talking about, before we talked about the included angle, now we're talking about the included side. So understanding that the included side is the side of a triangle between the two angles that we're referencing. So with that, it says here that the angle side angle congruency, or congruence, if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then those triangles are congruent. So as we look here, again, the state of Tennessee doesn't need a lot of this. We don't have to do our proofs, but what have they given us? What information have they given us? So looking at, given that BAC is congruent to DEC, so they have those labeled, and then BD bisects AE. So in that, we know then that this is equal to that because it bisects. So let's think about what we have. We have this angle, we have an angle, we have a side. We have an angle, we have a side. And then knowing what we do about vertical angles, we should be able to determine that those two angles are congruent because they're vertical angles, and therefore we end up having angle side angle of one triangle is congruent to angle side angle of another triangle. There we have it. So those are the kind of things that we need to be able to recognize and just sort of apply. And this is my included side. So I have an angle, included side, and an angle. So that is the side in between my two congruent angles that I'm referencing. So understanding the significance of included side, included angle. Okay, so looking at that. And again, here, we're not going to do a lot of this, but let's just think, what has it told me? It tells me here that XY is parallel to YZ. And then WZ is parallel to YX. And I will put 2. And then it wants me to prove that the two triangles are congruent. Okay, I do know. What do I know? I know that this is congruent to itself. And let's see, if I have two parallel lines, right? Two parallel lines cut by a transversal, then I know that my alternate interior angles are congruent. And then if I look at it from perspective of these two parallel lines, I know that my alternate interior angles are congruent. So I was able to identify some matching pairs or some congruent angles. And now when I look at this, I have an angle, a side, and an angle, and then an angle, a side, and an angle that would be angle side angle from one triangle is congruent to the angle side angle of another triangle, and then therefore I'm able to make that determination that this triangle is congruent to this triangle. Okay, so again, just sort of using those definitions of information that we've learned. And again, here's a good way to look at this, and I pulled this image out, just showing you that, we know that vertical angles, that is an example of not angle side angle, but let's take this back to what we were doing yesterday or in a previous class. We have a side angle side, a side angle side. So keep that in mind that these are different, but the appearance of an included angle and versus the appearance of an included side. So very similar, and we're just sort of, using that as a reference. So here, applying this angle side angle, and I'm not going to read too much here, but let's look at what's going on. It says, a company that manufactures windows needs to determine the amount of glass required to make the hexagonal window shown. Okay, hexagonal window. Tells me that PQ is parallel to TS. R is the midpoint of PT, so if it's the midpoint, we know then that those two things are equal because it bisects PT. And then ST is 12. ST is 12. Let's see, 12. All right, and then determine whether PRQ is congruent to TRS. All right, so if we look at this, and again, let's just apply some of those things that we've learned in previous lessons. I have two parallel lines cut by transversal, so I know that my alternate interior angles are congruent. Then referencing the other transversal, you know, my two parallel lines cut by this transversal, I know that my alternate interior angles are congruent. So I have angle. Now sides, if it's a regular hexagon, I know that all my sides should also be congruent. So that, and that should all be congruent because of a hexagon. And then there I have angle, side, angle, angle, side, angle. So I'm able to prove that those triangles are congruent. So there you have it, with that, using angle, side, angle. And then there you go. So looking here, finding the area. Now the area was a little bit more challenging. Find the area of the window. Well, we know the height, or we know the base. Could we calculate the height of my triangle? And we could possibly calculate the height of my triangle. So it says that the 6 triangles form a window that are congruent. The height of TRS is about this, inches. How much glass is required to manufacture that window? And then they use the area formula for a triangle. Okay. And I'm just sort of leaving this in limbo, but let's think about what did I need to determine this hexagon, okay? If we know that this is a hexagon, when we do our calculations, we know that this is 60 degrees, so all of these are 60 degrees. Right? Which makes one of these little angles 30 degrees, and we're not going to use trigonometry here, but what we can do is determine that if this is cut in half, this would be 6, and this would be 6 since the total length is 12. And then because of my base angles and I know that this is 60 degrees, right? Because it's an isosceles triangle. Now it's an equilateral, equiangular triangle, so I know then that this is 12. So I'm actually able to figure out the height by using the Pythagorean theorem. Okay, this would be my a squared, b squared, c squared. So that's how they came up with that height that they gave us. And then they were able to then multiply one window, find the area of one window, and then multiply it by 6, because there are 6 windows that they're trying to find. All right. Theater uses scaffolding to hang stage lighting, and the stage manager needs to determine how much electrical wire is needed to hang lights across the scaffolding from point L. So we want to go from L to N. Okay, now let's start thinking about what they've given us. LN is parallel to PQ. All right, so this line is parallel to this line. NP is parallel to MQ. NP is parallel to MQ. So 2 lines. Okay, so 2 lines cut by transversal. We're looking at that. I know that this LQ is parallel to MP. So there we can start looking at information. So depending on which set of parallel lines you want to tackle first, this is parallel to this. So then therefore, this angle is congruent to this angle. We know that this angle is congruent to this angle. I know that this angle is congruent to this angle. And then we start looking at all of the different information that we have. Let's see. MN is 4 feet. So this is 4 feet. Then how many feet of electrical wire is needed to display? Let's see here. This angle should be the same as this angle. As we start to look at some other details here, parallel lines cut by a transversal, right? So we know that these two are going to be equal. So what I can do is remove some of that. So I know that those two are going to be equal. Let's see. I know that this angle should be equal to this one because they're alternate interior angles. This angle should be equal to this one. So what I'll do is I'll remove some of those extraneous hashtags or arcs. Let's see here. So we should have this side. Oh my goodness. This piece should be congruent to this piece, and this piece. I'm just randomly putting in quantities there. That piece should be congruent. So now we have what would be angle, side angle, angle, side angle, and then that way we would be able to confirm that this is also 4. So just being able to, filter through a lot of that. It's a very small image to be calculating all this information on, but it looks like if we wanted to scaffold between display wires across the scaffolding, it depends on what points we're going from, but it looks like to go from L to N, we would definitely need 8. So let's see here. Moving on. Angle, side. So this is a little bit different. So two angles in the non-included side of one triangle are congruent to the corresponding two angles in non-included side of the second triangle. So here, again, this angle is congruent to this angle is congruent to this angle. The included side would have been, we were just dealing with the side in between the two angles, but now they're saying it's the side outside, not included. So there you go, not included would be able to prove that two triangles are congruent. So again, looking at this, we do know that, what do we know? And they're talking about it a little bit farther, that we learned that this is enough information to prove that two triangles are congruent. But think about what we had learned previously, that if two angles of one triangle are congruent to two angles of another triangle, then we know that the third angle is also congruent. And then if you notice, you look at this and you're like, hey, well, all of a sudden I have angle, side, angle, angle, side, angle, and then we have another way of proving congruency. So it just sort of gives us enough information to be able to continue on with our congruency statements. So again, angle, side, angle, this is how it would appear. We appear to have an angle, angle, side, angle, side, angle, side. Let's see here, looking at this, proving the angle, side. Let's just, we know here, what are we trying to prove here? Prove that this triangle is congruent to this triangle. And what we can, there's a lot of things that we can do here, but I know that vertical angles are congruent. I know that they're telling me that this side is congruent to this side. I know that we have two parallel lines cut by a transversal, So I know that this angle, this angle is congruent to this angle, and this angle is congruent to this angle. So I have enough information now to prove that these two triangles are congruent, because I do have, I have angle, side, angle, I have angle, angle, side. Just depends on which one we're going to use as a determining factor. So, but if they were asking me angle, angle, side specifically, I have right there, angle, angle, side, angle, 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 side. So we have enough information. Quickly expands. Let's see here. So looking at this one, I will tell you that we have two different triangles that we're trying to prove are congruent. And the easiest thing to do in this situation is to take and split the triangles up to where it's a little bit easier to see. When you have overlapping triangles, split them up and, oops, it was something like this. And then we have C, C, D, E, B, A, and somewhere here we have an F. Okay, and then I'm not going to worry too much about this, but let's see here. Given that DAC is congruent to BEC, okay, and DC is congruent to EC. They want to prove that those two triangles are congruent. And, well, what we know is that this angle C, is the same on both triangles. So we have enough information now. When we separate it, it's easier to see that you have angle, angle, side, angle, angle, side. Not drawn to scale because I'm not a machine, but we were able to get enough information on our image to make those determinations. Okay. So with that, the last method of determining that two triangles are congruent was often just referred to quickly as hypotenuse leg, and it's actually a very small reference in this text, but it's the main one that we'll refer to most of the times. But let's see, using a right triangle specifically, this is 90 degrees, okay, and they say, hey, leg congruence. Well, if you think about it, we don't need to have anything special for leg. This quickly looks like side, angle, side, side, angle, side. So it's not unique to a right triangle. Side, angle, side. The hypotenuse angle, again, not specific, that I have right here, side, angle, angle, side, angle, angle, or angle. We often look at that as angle, angle, side. This would be side, angle, side. So we've already covered those. Leg angle. Leg angle. They're saying, hey, here, leg angle looks something like this. Well, if it's a right triangle, we know this. And then they're saying if a leg and an angle are congruent, well, that looks again like angle, angle, side. So these are not new methods, but hypotenuse leg is. So we have, if the hypotenuse of one triangle, that's a horrible looking right triangle. We have a right triangle not drawn to scale, and they're saying if the hypotenuse and the leg of one triangle are congruent to the hypotenuse and leg of another triangle, then we have two congruent triangles. Okay, now don't be confused. This is a side, and a right angle. This is a hypotenuse leg. You have to have a right angle to have a hypotenuse. This is not the same thing as angle, side. This is hypotenuse leg. Okay, because you only get a hypotenuse if you have a right angle. So that is why this is actually unique, the unique fashion of it. So here, Craig and his brother are painting a house, and the brothers use ladders that are the same length. If they place their ladders at equal distance from the house, will each ladder reach the same height on the house? Construct logical arguments. And what they've done is they said, well, if I know they're saying that, that my ladders are the same length, my ladders are placed the same distance away from the house, and then the house, we know the wall is built at a 90-degree angle, or we're making that assumption, okay, that it's proper construction. So now I have a hypotenuse, a leg, hypotenuse, leg, and that right angle. So then everything else, we have enough to prove a congruent triangle, so whatever this height is going to be the same. So yes, it would be placed at the same location on the house. Here again, we are not going to do this, but we need to understand our definitions and use them. It says the fence has panel supports and a crossbar that forms two triangles. Okay, complete the proof, not worried about that. Let's look at the details. Given that angle B and D are right angles. Okay, again, immediately right angles. B and D are right angles. And AD is parallel to BC. AD, it's hard to see here, AD is parallel to BC. What do we know? Well, if it's parallel, think of, what do I know? If it's parallel, right angles, this hypotenuse is going to be equal to itself. And let's see, what else do we know? And I will say, if I have, again, two parallel lines cut by this transversal right here, that this angle is going to be congruent to this angle. And I actually have enough to stop there if I'm thinking about two triangles. I have a side, an angle, and an angle, and then I have a side, an angle, and an angle. So we have, angle, angle, side, or they call it hypotenuse, angle. That's one way to make the quick determination. So that's, let's see here. So with that, I'm able to make those determinations. So again, those are the 5 methods that we have gone over, which is going to be the hypotenuse leg, side, 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 angle, side, angle, angle, side, and angle, side, angle. And I will just reiterate here that hypotenuse leg, you have to have a right angle. There is no such thing as side, side, angle. It's hypotenuse leg because we have a right angle. So just keep that in mind. There is no side, side, angle, or angle, side, side in triangle congruency.